Good evening, everyone, and welcome to the January meetup of Austin Artificial Intelligence of Things. Due to the recent activity in the virus, we decided that we were going to do this one online. Um, we are, however, we're back to meeting live at the Capitol Factory, and our next month's
Good evening, everyone, and welcome
our next
to the
month's
January
meetup.
meetup of Austin.
Sorry about that. Like I was saying, we are back to meeting in person at the Capitol Factory. And for our in person events, just want to remind everybody that parking is available in the parking structure underneath the facility. And you have to get a voucher at the meetup, though. And with the voucher, that parking is only $7. I will be posting next month's meetup announcement very soon, hopefully by the end of this week. And we will be back right now, planning to meet back in person at the Capitol Factory starting next month in February. I think that's really all I have for the intro this month. And with that, I would now like to introduce and turn it over to Davit, who is going to give us an amazing presentation on data-centric AI practices. Take it away, Davit.
Thank you very much, Dave, for hosting this event, and thanks for everyone for coming to this event. My name is David, and I'm the founder of Activeloop. We are based in Bay Area, and today I want to talk about data-centric AI practices, as Dave mentioned. Let me just give you some background about myself. Before starting the company, I was doing a Ph.D. at Princeton University, and I was in a neuroscience department working with large amount of unstructured data. We were processing petabyte scale images of mouse brain, and one of the problems that we were having is that we were basically operating in the dark. We had so much data sitting on the cloud at petabyte scale, and we had to apply machine learning and deep learning to be able to extract valuable information from these data sets in order for researchers to be able to do science on top. And one of the problems that we had is that besides the data being unstructured, it also was very expensive to process it, and there were no tools, especially for deep learning applications, like detecting objects or segmenting doing semantic segmentation on images. We had to actually reinvent a lot of stuff that is already there for more traditional machine learning workloads or big data workloads that you might be aware of, about databases, data warehouses, and data lakes. And that's why we decided to start a company, move to Bay Area before that, and essentially start helping enterprise to manage their data sets. And what we have seen is that over the past 10 years, like the whole research community has been focused on optimizing models. Those models that do state-of-the-art detection, as I mentioned, about the objects, or doing natural language processing, audio processing, recognizing objects also from, let's say, sensory data like LiDAR or radar. And a lot of these revolutions gave the initiation of self-driving, let's say, effort that has been widely put down to be able to have the cars to drive themselves. But what we have missed, and what we have been so far focused before, is actually optimizing datasets. So we came kind of into a local minima in terms of optimizing models. And now, like, even if you want to run the so-called automated machine learning, you only get a couple % improvements. But if you go one step before and start to optimize datasets, you actually can get up to 5 to 10% improvement on the model without actually changing the model itself. And we have one of the prominent scientists in the field, Andrew Ng, who is pushing this data-centric AI, which is considered to be one of the hottest trends over starting from mid last year, and which basically says if you have better data quality, into the models, then you get much better precise models in the backend. And that's where we at the company are focused on. So what Activeloop does, Activeloop provides a solid data foundation for AI. First of all, we start a very simple and elegant API for creating, storing, and collaborating on AI datasets of any size. Then we help to rapidly transform and stream data while training those models at scale, and I'll explain you how this works afterwards. And more than that, sometimes neglected event is being able to clearly explore and visualize datasets. And this all for you to be able to get more accurate and cost-effective AI models to put this into the production. Could be for IoT, could be for robotics, and other many use cases that we have seen help our open source solution to be used. Before getting further, let me just try to clarify what we do. So first of all, we do provide a dataset format, which is open source, that helps to represent the data going from the unstructured, this mass, into actually structured tensors that are very native for deep learning frameworks such as PyTorch or TensorFlow. So what we do is that imagine you have 1,000,000 images and 1,000,000 labels, and then 1,000,000 images now are have separate files on your folder. And the way you are actually working, think of it, you are actually working with it as if you're on a Windows laptop, opening it up and then drag and drop. And you have, and the same way as data scientists are working at scale, so nothing is changing too much. And what we found out is that it's pretty inefficient to work like that. So we take this 1,000,000 images and then transform them into n-dimensional arrays, which could be like 1,000,000 by 512 by 512 by 3, and then very efficiently chunk them and store them on a backend storage, like could be an object storage like S3, or could be your local file system, and such that the deep learning from that data becomes very efficient. The difference what we do is like a lot of times data scientists spend much of the actually time is spent on pre-processing the data into the form where a model can consume. But usually the raw data itself is stored in the format that has been used or optimized for non-deep learning applications. And that's what we are kind of trying to shift, is that actually maybe it's much better to store the data in a structured form where your models can directly consume. And that's actually not only saves the performance or the compute time to run your models, but also saves the data scientist time to actually work with this data or collaborate on across many teams. So the main core thing that I want to focus on today is about copying the data. Let's say you're a data scientist, you have your own laptop, you have a notebook on the cloud, or you have a multi-GPU training setup that you train a model on multiple machines, or you are running a large inference job. Every time you start a process, you have to take the data from the source and then copy to your laptop, to your notebook machine, to your training job or inference job. And this takes a lot of time and also effort for making sure that there's a consistent data has been transferred to the location that you are doing the data science on top. And more than that, not only copying is the issue, is that let's say you went and then modified from the source some sample or edit more data. Now you have to go across all of these endpoints and then synchronize the data again, which becomes like sort of an impossible thing to do. And it's very similar how we were shipping like DVDs of movies like 20, 30 years ago, around 20 years ago, to individuals to watch a movie. And instead, you can now think of it, okay, what if we can actually take the data and then stream it? So instead of copying the data, now the data is getting streamed whenever the data scientist is accessing the data or the worker is like starting to train the model. So the main difference is that no longer you need to copy the data. Now you can actually like stream the data as if you're watching Netflix to the models to process this data very efficiently. And one of the main things that I would like to focus on is that it makes it much easier and convenient to operate on large scale of many number of data sets while we, as a team, accessing different parts at the same time and then working with it. And you might ask, okay, what's the kind of the main benefit being able to separate the data distribution from actually the computation itself? And one nice thing, what we have seen is one of the data sets that Google has published, and we collaborated with them on representing their Google Objectron dataset, which is one of their most popular internal datasets for identifying images or objects from the images. That we have seen that like an average data scientist who wants to access this dataset, which is like 2 terabytes, it takes like up to from 25 hours to 41 hours to download the zip files, unzip them, understand their API, and then finally load the data so that you can access a particular slice. With us, instead of doing that whole processing, like it takes 5 seconds, like basically just install our Python package and then import any part of the data set, and you can start like either connecting to the PyTorch or TensorFlow to train your models. The main thing is what we are doing is that we, behind the scenes, we asynchronously copy the data from the data storage that has been stored in the data set while you are working with the data or while the model is consuming the data set. And you might ask, okay, what about the performance? Because we know that the network overload could be very big across large data sets. And apparently, what we have seen, let's say if you are doing the training process on the cloud, on AWS for this case, and furthermore, you have the cloud machine and the storage are more or less are in the same data center. If you want to train a single ImageNet, which is one of the classical computer vision data sets, once it actually takes 3 hours, 21 minutes just to copy the data file by file to your machine, to train for 1 hour and 5 minutes. They recently introduced a fast file mode, which actually can map a file system on top of object storage, which now lets you to get instant access to the data, since the file system is not aware of what kind of computation you're doing, it's like the context is not there. Now the training time takes 2 hours. And with us, you can actually boil down to 1 hour, 7 minutes of training time, which is very similar to as if the data was local to the machine, but actually without copying the data. So while the data is being copied or transferred over the network behind the scenes, your GPU infrastructure, which is one of the most consuming and expensive resources you have, is actually running the computation. And on top of that, we do also provide a platform where you can visualize the data, and I'd love to actually show you this today. So if you go to Activeloop app.ai and go into one of the datasets that we do provide here, you can see actually this ImageNet that I mentioned, where you can focus on a single element and explore. Okay, you can see here's the image and the labels and what they are saying, and you can also like very rapidly go and look into various instances of datasets or examples that you can see. And furthermore, the same way as we mentioned about streaming the data to the compute workers, now we can also compile this onto the browser and directly stream the data from, let's say, an S3 storage to the browser without any middleman. So there is no any, let's say, backend or rendering engine that sits in the middle of my data and my browser to be able to stream this. And both in terms of the security and also performance, it's much better. We also do provide like multiple public datasets that you can get access to it now very easily. And furthermore, the platform itself is able to not only visualize the datasets, but also you can look into analytics of the data, like seeing how many masks, what are the bounding boxes, how big are they, the categories, the distributions of the data. And you can also go into the version control and say, okay, I can create branches of my dataset while I'm working with a team of datasets, and then I can easily see, okay, what is the difference between my one branch, which you will see is like kind of sharpened images, and the main branch. And furthermore, you can go and back see, okay, here's one of my teammates. He did this contribution a few months ago. How was the dataset look like at that time? And you can easily explore the datasets on that go. One thing that we do additionally provide as well, that you are able to run queries on the data. So let's say I want only the images that have koala on site. So you can say, hey, give me all the images that contain a koala. And then Now the query goes to the backend. The backend actually starts the workers that stream the data to the backend to run the computation behind the scenes. And then now what we'll see, hopefully, if everything works, all the performed, like all caller images actually filtered over the ImageNet dataset. And those are the examples that are being loaded. We do have much more complicated datasets as well with videos or sensory data as well, and we are planning to add more radar and LiDAR visualization on top of this. And of course, you can go into look into more segmentations, different bounding boxes, and everything depending on what kind of use cases you are working at. And as I mentioned, one of the important things that we often neglect is actually being able to visualize the data and very efficiently understand the quality of it. If there are any failures, if there are any mislabels, or if my models did a wrong prediction, how can I easily detect this? And that's where we believe like Visualizer adds a lot of value to this. So if we sum up in terms of the features, we help to manage the data, either it's on the cloud or on on-prem devices. We help with the streaming of the data instead of copying the data. And we also have a lot of integrations with other deep learning frameworks, clouds, and other software that you can easily plug into and use it. And soon we are also releasing, as I mentioned, version control, which is in alpha currently. Being able to query that I've demonstrated today, like you can take a subset of the data and then push it to the training, and being able to run transformations on the cloud at scale without worrying about the infrastructure. So this was like sort of short summary of what we are doing and what kind of data-centric AI practices there are and how Activeloop is helping the effort. Thanks a lot for your attention. If you have any questions, feel free to post a comment, and I believe we'll help you out and answer the questions. If not, feel free to join our Slack community. And also, we do have a special gift for the watchers in the community here. If you ping Mikhail, then he will be able to provide a free storage up to 500 GB on the platform itself. And as I mentioned, the Python package that we work with, we can just pip install help, is open source and free to use. So yeah, let us know if you have any questions or any feedback that we can be helpful to you. We'll give maybe a couple minutes more. If you do have anything you would like to ask, more than happy to answer now, or otherwise feel free to join us and we can take this offline and answer any questions you might have.
No, if I talk, can they hear me on the YouTube channel? Hello, everybody. I'm going back to being quiet now.
Mm-hmm.
Yeah. Well, again, I just wanted to thank everyone who joined us this evening. And as Davit said, we can take this offline if anybody wants to explore this further. Maybe we could even come up with a project that we can all work on together to utilize Activeloop. So if anybody's interested in that, please let me know. And again, please watch for the announcement for our February meetup. And that should be coming up soon. Thank you, Davit. We appreciate you taking your time to do this. And thanks everyone else for attending. Have a great night.
Thank you very much for hosting, and great to meet you, everyone.
You're welcome.